Hi there, welcome back to our channel, and we continue our discussion on very fascinating topics such as semiconductor devices, electronic circuits, sensors, etc. And this time we have brought to you an explanation about the bipolar junction transistor, and in particular we are going to discuss the H parameter model, H parameter model of BJT. So when you do a small signal analysis or a large signal analysis of a BJT, what you do, you want to understand the behavior of the transistor in terms of its equivalent circuit. So small signal represents the behavior of a device with respect to AC signals, and the large signal analysis represents the behavior of the device with respect to DC biasing conditions. So in that category, we are talking about the H parameter model. So remember, we have explained to you there are three configurations of the transistor: common base, common emitter, and the common collectors. And this particular H parameter model of a BJT is applicable to all these three configurations. So what you do is your input signal VI, your output signal VO, and there are these terminals, number one, number two, and number three. Remember, BJT is a three-terminal device. So whether it is an NPN transistor, this is collector, this is emitter, and this is base, or your PNP transistor, this is emitter, this is your collector, and this is your base, depends on that. So this model is applicable to both of these devices, and depending on whether you configure or bias your transistor in CB, CE, or CC, the name of these terminals can be indicated. For example, I am going to explain you the H parameter model of a BJT for common emitter configuration. So let's call the terminal 1 to be base of the device, terminal 3 is the emitter of the device, and terminal 2 is the collector of the device. So obviously your VI is going to be VBE. Okay, it is same as VBA. Now you have II, that is going to be IB. This is your input current. Okay, now your output current IO will be your collector current IC. And when we talk about, let's say, a small signal AC analysis, I will use the small case letters. When I will talk about the DC analysis, I will use the large case letters. For instance, let me write it properly. When I talk about VBE, I will write in this way. So it is VBE. But the same, this is for the AC case, and for the DC case, I would write VI is VBE, all capital letters. Then you have II or I1, that would be my IB, base current, and IO would be the collector current. I see. So we continue with the explanation. Now, what is uh, HIX? Remember, before I explain these parameters, X here, and X here, and X here is either E, B, or C. So E stands for emitter, B stands for base, and C stands for collector. So I would say, in terms, we are talking about the H parameter model for a CE configuration. So I would say HIE, which is basically HIX. and this is your this is output current, output current. This is your input current, input current. This is your input voltage, input voltage. And now HIE is your input impedance, input impedance of the circuit. Okay. Now, I will write another parameter. Let me just scroll it down. That is my HFX. It will be, X will be replaced by HFE. So this is basically, I would say, forward current gain. Forward current gain. So remember, this is your input side of the circuit, this is your output side of the circuit. How about HIE and HFE? In terms of DC, you will write them like this. F will be capital and E will be capital. Similarly, HIE, or simply say HIE, something like that. Okay. So remember, when you say HFE in a capital one, that is DC gain of the transistor, which is often mentioned in the data sheet. And when you see a small HFE, is like that, and FE are small letters, remember that is small signal current gain. That is the gain for AC. Remember, now this HFE, let's not get confused. We would say this input impedance is not basically mentioned in the small letter or capital letter in the data sheet. So we will keep it as it is. Like HIE would be, let's say it will be given for a small signal analysis. Now, there is one more term, that is your HOX, which is when X is replaced by E, that becomes your output admittance, admittance, or 1 over HOE would be your output impedance. So usually you take a reciprocal of HOE, that is your that becomes your output impedance. Now there is now HRE, HRX actually, which is then HRE. This is the reverse gain of the transistor, which is basically a representation of your IB versus VBE characteristics for a given value of VCEs, right? So for the input characteristics, you have this. So reverse gain is just like you feed the transistor from the output side and you measure the output from the input side. And the forward current gain is you apply the input to the input side and measure the output, take the output from the output side. So you see now we've got all these parameters covered, and this is pretty clear with all the parameters, HIX, HRO times VO. So that is your gain in the reverse direction. This is your forward gain, HFE times the input current, or you can say the this gain, and this is the output admittance or output impedance. So this is how the H parameter for a BJT works. Okay. Now, when you basically see in the data sheet H, just small letter, and F and E in the capital letter, that is a DC gain of the BJT. You can also represent that by letter beta. So the beta indicates that gain, beta DC or simply beta, that is simply a DC gain of the parameter which is often found in the data sheet. Okay, so This model is a small signal model or a DC model, depending on which analysis you are doing, for a low frequency. This is well suited for a low frequency applications. When you want to operate the circuit or devices incorporating BJT for a high frequency analysis, then the inter-electrode capacitances, which are important at high frequencies, must be added. So you will have to add the capacitances in the model, but that we'll see somewhere some other time. Okay, so that's all. So this is how you understand your parameters for it. What about you? I ask you to draw the model for the CBE, common base configurations. So common base configurations, let us try to draw it. You have like this terminal, this will be the base, then your input terminal will be the emitter, and then your output terminal will be your collector, right? So you got to understand how the model can be drawn. So your input current I1 would be like this, and then just go up right here how you have done. You have to take these input impedance into account. So this will be your input impedance, HIX, but that HIX will now be your HIB, okay, not HIE, because you are talking about common base. And then your reverse gain will be HRX times the VO. It would be same. And HRX will become HRB, right? So just let's draw it in this way. 1 second. Let me draw it. So I keep it that exercise. I leave it as an exercise to you. Just write in the comment box or upload your figure for the model and let me know. So stay tuned for more informative contents.